All right, y'all, today we're going to be talking about writing quadratic functions. And what's big about writing quadratic functions, the last couple of notes, we really focused on identifying the forms and really pulling information out of the forms, such as vertex, axis of symmetry, y-intercept, roots. Today, we're going to be taking some of that information and actually trying to write or create equations based on that information. So the first example we're going to look at is example 1. We want to graph the quadratic function um, that has a vertex at -3, 4 and passes to the point -4, 1. And then we want to determine the equation of that quadratic function. So let's go ahead and plot those points. So -3, 4 and -4, 1. 1, 2, 3, 1, 2, 3, 4. And 3, 4, and then 1. Okay, and we can already see if that is our vertex and then our next point is down, that we know this is going to be a downward facing standard function that we be plugging into. So we kind of have an idea already of what our quadratic function is actually going to look like. Now, in terms of writing it, we want to use the information we have. So they have given us the vertex. So that means I already know my h and k, which means I already know 2 out of the 3 of my variables for my vertex form. So I'm going to go ahead and plug that -3 and 4 into our vertex form equation. So y is equal to a, which I still don't know, x, and then not minus, but plus 3, because it is always opposite, squared, and then plus 4. Okay, so this is what I already know based on the information that they gave us. I already know my h value is -3, so positive 3 in the equation. And I already know my k value is 4 or positive 4 in my equation. Now, the second piece of information that they've given us is that it also passes through the point -4, 1. Now, -4, 1 is, of course, a nice, lovely x, y point, which means if I plug it in for x and y in my vertex equation there, I can solve for the only unknown variable that I don't currently know, which is that a value. So if I plug in 1 is equal to a, and then plugging in -4, plus 3 squared, plus 4. From here, I can just simplify and I can solve for that a value. So 1 is equal to a -4 times, or -4 plus 3 would be -1 squared, and then plus 4. From there, -1 squared would give me positive 1. So 1 is equal to a plus 4. Then from there, I can minus 4 and minus 4. So we do get an a value of -3. So now that I know my a value, I have everything I need to go ahead and plug into my equation. So y is equal to -3 x plus 3 squared, and then plus 4. Okay, and it is always good once you get everything plugged in to come back to your graph, to come back to our equation, see if that makes sense. So it shifts left 3 and up 4. It is -3, so it's going down. And based on that first set of points that I have, it does look like I am vertically stretching by about 3. So I would say this quadratic function matches up pretty well based upon the points that they gave us. Okay. So let's pivot a little bit and let's look at example 2. So on example 2, they want to graph the quadratic function that has x-intercepts at -2, 0 and 2, 0 and passes through 1, -6. Okay, So this time they're giving us a different set of information. They're telling us what those x-intercepts are. And so really remember and keep in mind, we have those three different forms of our quadratic equations, and we're going to use those various different forms depending on the information they give us. So since they gave us x-intercepts or our roots, we want to use factored form this time. So our factored form is y is equal to a, which I still don't know a, but then it is x minus 2 and x plus 2 from my two roots. Okay, and then once again, they gave us an extra point, -1, -6, which is, of course, an x comma y point. And I got a little ahead of myself. Let's go ahead and graph this real quick just so we have an idea of what this should look like as well. So -2, 0, and 2, 0, with the extra point -1, -6. 1, 2, 3, 4, 5, 6. So we can definitely see just from what we have that we're probably going to have an opening up quadratic function, which means we're looking for an a value that is positive. Judging on how far apart I am from my roots and that next point, I'm probably looking for something with a pretty substantial vertical stretch as well. So let's see if that bears out as we solve this out. Okay, so just like on example 1, once I have plugged in based on the information they give us, I'm going to go ahead and plug in that x comma y point, that extra piece of information that they gave us. So ours is -1, -6, so -6 is equal to a, which I still don't know, and then -1 for my first x value, minus 2, and then -1 again for my second x, but then plus 2. Okay, and then simplifying from here, we get -6 is equal to a. -1 minus 2 would be -3. -1 plus 2 would be +1. Okay, multiplying across, we do get that -6 is equal to -3a. And then, of course, dividing by -3 and -3, we get +2 is equal to a. So now that we have our a value, I can go ahead and plug that in back to my original equation. So y is equal to 2 x minus 2 x plus 2. All right, and that's all there is to it, y'all. It's really that straightforward. Plug in the information that you know, and then they're going to need to give you at least one extra point so you can plug in that x and y and solve for whatever variable you don't know, be it a or r or h or k. Whatever you don't know, that's what we're going to solve for. And just kind of checking with our equation once again, we have a 2, which means should be opening up, looking at our quadratic function. I would definitely say we did a pretty good job of that. Our vertex probably about right here. And so it would give us that nice little quadratic function like so. Okay, I want y'all to go ahead and do example 3, A and B. Go ahead and pause the video, try each of those real quick, and then you can check your work with me here in a moment. All right, I'll go ahead and check your work on the screen. So on example 3, we plug in that vertex of -2 and +1. Then we plug in that point of 4, comma -2. Simplifying all the way through, we do get an a value of -3/4. So we get y is equal to -3/4 x minus 2 squared plus 1. And then over on our B, same thing, but this time in factored form because they gave us those x-intercepts. So y is equal to a, x plus 1 times x minus 4. Always opposite when we're plugging into those fractions, or not fractions, into those parentheses. And then plugging in that extra point they gave us, so 4 for the y value, 2 for the x value. Simplifying through, we do get an a value of negative 2/3. So y is equal to negative 2/3, x plus 1, and x minus 4. Okay, so fairly straightforward on both of those, y'all. Same skills that we practiced last time. Now let's go ahead and flip on over to the back and let's talk about one last type of writing quadratic function that we're going to explore. And this one's going to be a little bit more involved. So we want to graph the quadratic function that passes through those 3 points, negative 1, 5, 0, 3, and 3, 9. And then they want us to determine the equation of the function. So those 3 points, negative 1, 5, 1, 2, 3, 4, 5, 0, 3, and 3, 9. Okay, give us kind of an unclear picture of our quadratic function at the moment. But if you do notice, one of the points that they did give us is they did give us that c value. So the c value is the y-intercept. So since they've given us the y-intercept, we do want to go ahead and write an equation in standard form. So y is equal to a x squared plus bx, because I don't know a and I don't know b, but I do know that c value is 3, so we're going to go ahead and add on our plus 3. Okay, so this is our first piece of information they've given us. Now the second piece this time is they've given us 2 different points that it goes through, but those other points, they're not a vertex, they are not the roots, they're not any other remarkable points. But what we can do is we can actually plug in both of those points to our standard equation and then kind of see what that sets us up with. So let's go ahead and start out by doing our first point, which would be negative 1, 5. So 5 is equal to a parentheses negative 1 squared plus b parentheses negative 1 plus 3. Simplifying just a little bit, we get 5 is equal to negative 1 squared is 1, so just 1a, and then minus b plus 3. Okay, and then same thing again, but we're going to use our other point, 3, 9. So 9 is equal to a parentheses 3 squared plus b parentheses 3 and then of course I do still have that plus 3. So 9 is equal to 3 squared is 9, so 9a plus 3b, and then my plus 3 down here at the end. So I have 5 equals a minus b plus 3, and I have 9 equals 9a plus 3b plus 3. Okay, so you might be thinking, don't really know what we achieved here, don't really know what we figured out. What we did figure out is we now have 2 separate equations, each with 2 sets of unknowns. And we can actually simplify these a little bit more by combining those like terms. So minus 3 and minus 3. We do get that 2 is equal to a minus b. And then same thing over here, minus 3 and minus 3. We do get that 6 is equal to 9a plus 3b. Okay. And from here, we have these 2 different equations that we can actually use them as a system of equations. And if you remember system of equations from Algebra 1, there's 2 different ways we can solve the system equations. We can solve by substitution, which means we would want to isolate one of these variables and then plug in to the other equation, or we can do it by elimination. I'm going to show you both methods just since it's been a while since you've done system of equations. And kind of as a good refresher. So our 2 equals a minus b. I'm going to go ahead and start with that because it will be fairly simple to solve this for one of my variables. So I'm going to add b and add b. So we get 2 plus b is equal to a. Okay, and then I can take that equation 2 plus b is equal to a, and I can plug it in to my other equation, which is 6 is equal to 9 parentheses. And then instead of a, I'm going to do 2 plus b. And then, of course, plus 3b. So from here, I can just multiply and simplify a bit. So 6 is equal to, let's go ahead and multiply this 9n. So 6 is equal to 18 plus 9b plus 3b. Combining some like terms, 9b and 3b does make 12b. Then, of course, minus 18 and minus 18, we get negative 12 is equal to 12b. Divide by 12, divide by 12. We get negative 1 is equal to b. Plugging into our other equation, 2 plus negative 1 for that b that we just got equals a. So we get 2 plus negative 1, so 1 is equal to our a value. Now that I have b and I have a, I can plug back into my standard form equation. Which gives me a final equation with my a value of 1, b value of negative 1, and c value of 3. Y is equal to x squared minus x, and then plus 3. Okay, and we call this our substitution method. Okay, so our substitution method, we take one of the equations, we isolate one of our variables, and then we plug that in to our other equation. Now, maybe you don't really like the substitution method. Maybe you want to do elimination instead. Now, elimination is also rather straightforward. The big thing with elimination is we want to have a set of variables that are the same. So right now I have 2 equals a minus b, and 6 equals 9a plus 3b. So everything's lined up, but right now, if I added these two equations together, I wouldn't get anything to eliminate. So what I want to do, I'm going to multiply this first equation by 3, and that would give us 6 is equal to 3a minus 3b. Okay, and if I do that, then I can add these two equations together, and adding these two equations together, 6 and 6 would give me 12, 9 and 3 would give me 12a, but 3b and negative 3b are going to cancel out or eliminate, which is why we call it elimination. We get 12 is equal to 12a, which then, of course, we can divide by 12. Divide by 12. We get 1 is equal to a. Then just like before, I can take that a value and I can plug it into my other equation. So 2 is equal to, parentheses, 1 minus b, minus 1 and minus 1 to both sides. We get 1 is equal to negative b. Divide by negative 1, divide by negative 1, and we get negative 1 is equal to b. So relatively straightforward. One method, like I said, is substitution. Our second method, once again, we got a as 1 and b as negative 1. This is what we call elimination. Ooh, wrong piece. And you can use substitution or elimination when solving for these 3 different points. And either one of them, substitution or elimination will get you, as you can see, to those same coefficients and to that same final equation, y equals x squared minus x plus 3, which, of course, if we wanted to kind of finish out our quadratic function, does give us something to about that effect. All right, y'all. Well, I know this one was a little bit long-winded, especially example 4, but that is writing quadratic functions in a nutshell. Go ahead and complete some practice, and don't forget to make sure you take your exit ticket.